Look up at the night sky. Beyond the city lights, past the moon's glow, a tapestry of stars stretches across the darkness. But among them, something else moves. A silent point of light gliding with purpose. It's not a star or a plane. It's a satellite, a sentinel placed by human hands. These silent watchers are the invisible web connecting our world, enabling every phone call, weather forecast, and image of our planet. Imagine a world without them. No instant communication, no global navigation, no early warnings for storms. Their journey begins with the thunderous roar of a rocket, a violent birth for a machine destined for quiet precision. Once in orbit, it unfurls its solar wings, ready for its lonely vigil. Satellites are more than machines. They're symbols of our curiosity and ingenuity. They connect us, shape our lives, and quietly architect the future. As we fill the void with these artificial stars, we're not just building tools, we're creating a new digital layer that envelops our world. These satellites are active participants in our daily lives, shaping our destiny as a species. They are the silent architects of the future. Their story is our story, a story of ambition, discovery, and the endless quest to understand our place in the universe. How do satellites stay up there? They're not floating, they're falling, endlessly. Imagine throwing a stone so fast that as it falls, the Earth curves away beneath it. That's an orbit. It's a delicate balance. Gravity pulls the satellite down, but its speed keeps it moving forward, trapped in a perpetual fall around the planet. In low Earth orbit, satellites travel at 17,500 miles per hour, circling the globe in just 90 minutes. Further out, in geostationary orbit, satellites match Earth's rotation and appear to hover in place. This cosmic dance is governed by the same laws that keep the moon circling Earth. Achieving orbit isn't just about escaping gravity. It's about hitting the right speed, altitude, and trajectory. A tiny miscalculation can mean failure. Launching a satellite is like threading a moving needle from hundreds of miles away. This is the beautiful, unseen mathematics that holds our technological world together. Every orbit is a high-speed waltz on the edge of the void. The precision is breathtaking, and it all happens far above our heads, every single day. What are these silent watchers doing? There are messengers, guides, and scientists. Communication satellites relay signals across continents, enabling calls, broadcasts, and internet. Navigation satellites like GPS guide our ships, planes, and cars with pinpoint accuracy. Earth observation satellites monitor weather, track deforestation, and watch over our planet's health. They provide the data we need to protect our only home. Scientific satellites like Hubble and James Webb look outward, peering into the cosmos, revealing distant galaxies and the origins of the universe. Each type of satellite serves a unique purpose, but together, they form the backbone of our modern world. They are impartial witnesses, tireless explorers, and the lighthouses of the 21st century. Their data tells the story of our changing world. They help us understand where we are and where we're going. Satellites are our eyes, ears, and outposts in the void. How do we talk to satellites? Through radio waves, a language we can't see. Satellites are sophisticated two-way radios, using transponders to receive, amplify, and retransmit signals. Ground stations send focused beams up, uplinks, and satellites send them back down, downlinks. The signals are encoded with digital information, voices, data, images. Different radio frequencies are used for different purposes, carefully chosen to avoid interference. Signals travel at the speed of light, but the vast distances create a slight delay, noticeable in international calls. Most satellites are powered by solar panels, converting sunlight into electricity and storing it in batteries. This energy keeps them running, even when they pass into Earth's shadow. In a very real sense, satellites are solar-powered beings, living on the light of our star. What's inside a satellite? At its core is the bus, the main body that holds everything together. Attached is the payload antennas, cameras, or telescopes, depending on the mission. The satellite's brain is an onboard computer, managing all functions and processing data. It must be robust, reliable, and shielded from space radiation. The attitude control system keeps the satellite stable and pointed in the right direction, using sensors and tiny thrusters or reaction wheels. Power comes from solar panels and batteries. Thermal control keeps electronics at the right temperature. insulation, radiators, and heaters protect against extreme heat and cold. Every system must work flawlessly. There's no repair shop in space. Each satellite is a marvel of engineering, designed for years of silent service. It's a self-sustaining explorer, built to survive the harshest environment we know. Our journey to the stars began with a simple beep, Sputnik 1, launched by the Soviet Union in 1957. It was just a metal sphere, but its signal echoed around the world, marking the dawn of the space age. The US quickly followed with Explorer 1, which discovered the Van Allen radiation belts. The 1960s saw rapid advances. Tyros 1 sent back the first weather images, and Telstar 1 enabled live transatlantic TV. Satellites evolved from scientific curiosities to essential tools, reshaping society. Today, thousands of satellites form vast constellations, mapping our world, enabling communication, and exploring the cosmos. We've sent satellites to the Moon, Mars, and beyond. They've helped us understand our planet, our solar system, and the universe itself. From a lonely beep to a global network, satellites have transformed civilization. Their story is one of ambition, innovation, and discovery. Each new launch adds a note to the symphony of technology above our heads. The space age is still young, and the sky is no longer the limit. Where are we headed? The future of satellites is mega constellations, thousands of small satellites working together in low Earth orbit. Projects like Starlink aim to bring high-speed internet everywhere, bridging the digital divide. But space is getting crowded, with thousands of satellites and even more debris, posing risks to future missions. Managing orbital debris is a critical challenge. Miniaturization and autonomy are changing the game. CubeSats make space accessible to schools and startups, while AI lets satellites make decisions on their own. Satellites will soon serve as relays for Moon and Mars missions, navigation beacons for rovers, and platforms for building interstellar probes. They're the infrastructure for humanity's next great leaps. The silent watchers of today are paving the way for tomorrow's explorers. The void is becoming a bridge to new worlds. Our journey among the stars is just beginning. From a beeping sphere to a global network, satellites connect and protect us, reflecting our ingenuity and ambition. Every time you check the weather or use GPS, you're part of this legacy. The universe is vast, and our exploration has only begun. The sky above is now an extension of our world, filled with our creations and dreams. The quest for knowledge is endless. Each answer leads to new questions. The story of satellites is just one chapter in humanity's journey. Keep looking up, keep wondering, and join us as we explore the mysteries beyond our world. Subscribe to Daily Magazine for more journeys through science and technology. What fascinates you most about satellites? Share your thoughts below. Your curiosity shapes our future.